Hello my dear students, welcome back to my class. I am your physics faculty. So last time means in previous classes we have discussed so many topics. So today I will be starting power of lenses, and after that power of thin lenses in contact and like this and prism and all, and if time allows we will discuss optical instruments like microscope, like simple microscope, compound microscope. So let's begin the class with power of lenses. Okay, come to the board. Okay, so here power of lens. Okay, so first let me tell you what is power of lens. Actually the power of lens is the measure of convergence or the divergence when the light falls on it. Suppose, as you know, say here is I have drawn a convex mirror as a convex lens as well as what, concave lens, right. So as you know, the convex lenses are converging in nature, right, they are converging in nature. Okay, and then when we say concave lens, they are what, they are diverging in nature. So the power of lens is nothing but the measure of this convergence as well as the divergence. Okay, let me give you the definition with the help of a proper diagram. Say I am considering a concave lens. So this is a concave lens. Okay, so this is the principal axis, and say this is a ray. So this is a ray falling parallelly, and since this ray is parallel to the principal axis, so after refraction it will passes through the focus, right. Say this is optical center, and say this distance of this point from the optical center be h, and as you know the distance of the optical center and the focus is measured by focal length. Is it clear? This is denoted by f. So the power of lens can be defined as the tangent of an angle. Say here you see this is the actual direction of the ray, but due to refraction it bent along this direction. So how much it is bending? If we measure the angle, this is delta, represents the measure of bending. So power of lens can be defined as the tangent of the angle, okay, by which the lens converges that particular ray, right. So we can write this is the power of lens, that is what, tan delta, right. So if I use the trigonometry here, so as you know tan means p by b, perpendicular by base. So here is the perpendicular, so this is h, and there is the base, so this is cf. So I am just directly writing the measurement of cf, that is f. Okay, so let me give you the definition now. Power of lens can be defined as the tangent of angle by which it converges or diverges the light falling at a unit distance from the optical center of the lens. Okay, optical center of the lens. Okay, I hope it's clear now. Okay, so now I'll give you the deduction or formula for the power of lenses. Okay, now look here. So from the diagram, as we can tan delta equal, say this is h by f. As I mentioned here, it is falling at the unit distance, means the distance between the this particular point and the point C, that is h, is nothing but 1, because this is unit. So I can write tan delta equal to 1 by f. Again, for these rays are paraxial rays. So these paraxial rays are very close to the principal axis. It means that angle delta is very small. So in place of tan delta I can write delta, say this is 1 by f. This is the expression for power of lens, and delta I can replace this by p equal to 1 by f. Okay, so this is the expression for power of lens, and SI unit of power of lens is diopter. So diopter, and in short it is denoted by capital D. Or if you want to express in meter, as you can see, focal length is measured in meter. So in place of diopter I can write meter inverse, because this is 1 by meter, so I can write meter inverse. So sometimes in exam the question might be like this: define 1 diopter. Okay, let me give you the definition. The 1 diopter. So 1 diopter, when we get 1 diopter, so this is P equal to 1 by F, right? So now if I take F equal to 1 meter, then I'll get what? F equal to 1 by 1 meter. So this will give us 1 meter inverse is nothing but 1 diopter. So 1 diopter means the power of lens. 1 diopter means it is nothing but the power of lens which has focal length of 1 meter. Is it clear? So what is 1 diopter? It is nothing but the power of lens having focal length 1 meter. Okay, this is about the power of lens. Okay, now we'll study the power of lens when we combine 2-3 lenses together. So this is called power of lens in contact. Power of thin lenses in contact. Okay, now you have to remember one point. Okay, for concave mirror the power of lens is negative, and for convex lens, we are discussing about the lens, right? So for concave lens the power of lens is what? Negative, and for convex lens the power of lens is what? Positive. Okay, so here, so power of lenses in contact, so I will combine two lenses. So this is one lens, say I'll consider this as lens A, and say this is another lens, so I'll consider this lens as the lens B. Okay, okay. So suppose the focal length of this lens is suppose f1. So focal length of lens A is f1 and focal length of lens B is what? f2. Okay. So now let's understand how the diagram will form. Okay, how the image will form. So here I have placed one object. This is a point size object O. Okay, so this is the ray, this is one ray, and this is another ray. Okay, so it will suffer refraction, and here it will form an image, say I1. Okay, it will form an image what? I1. And now you see, so this is the image for the object O formed by what? Lens A. And now since this I1 is the real image, so since this is real image, this will act as the virtual object for this lens B. Okay, and then the final image will form at point I. Okay, I hope it's clear. This is the whole process. So you can for explanation you can go through the book. So you can write like this: let us consider two lenses A and B having focal length f1 and f2, and you have to make sure that this lens is what? Convex lens. Okay, so the first, let us keep an object, point size object O on the side of what? Lens A. First the image is formed at I1, and I1 act as the virtual object for lens B, and the final image will form at what? I. Okay, so for this lens A, this is object distance, and here, okay, now remember one thing, this gap is negligible. Okay, this gap is what? This gap is negligible. So now from here, so this is image distance for lens A, and now this is image distance I is the image distance for lens B. Okay, so now as we have already derived the lens formula, so let me remind you lens formula: 1 by V minus 1 by U equal to 1 by F. This is what we have already derived. So let's apply this for the lens A. Okay, for lens A, so you can write here applying the lens equation. So I can write, so here the image distance is what? 1 by V1, right? Image distance is what? For lens A, 1 by V1 minus object distance is 1 by U equal to what? 1 by F1, as we have already considered F1 is the focal length of lens A. Say this is equation number 1. Okay, for lens B. Okay, for lens B, now you have to be very careful for lens B. Now you look here, for lens B, which one is the object, O or I1? So as I already told you, right? So I1 is acting as an object for this lens B, so V1 is counted as the object distance. So I can write here, and this V is what? Image distance. So according to lens formula, 1 by V, 1 by V1 equal to what? 1 by f2, because f2 is what? Focal length of lens B. Okay. So now I'll add these two. So now adding, so I'm writing in short, adding equation 1 and equation 2. So I can write 1 by V1 minus 1 by U1 plus 1 by V minus 1 by V1. So I'll write here, okay, equal 1 by F1 plus 1 by F2. Okay, now here 1 by V1 like terms but opposite sign, so I can cancel out. So now my equation reduced to 1 by V minus 1 by U equal to 1 by F1 plus 1 by F2. So I'm just rearranging the equation. If you want, you can write minus 1 by U. Sorry, this is only U, right? So by mistake, sorry. Okay. So 1 by V minus 1 by U equal to 1 by F1 plus 1 by F2. Okay. Now if I consider these two lens system as a single lens having focal length f. Okay. I repeat, if I consider these two lens system as a single lens having focal length f, so what I can write here, in place of 1 by V minus 1 by U, by using lens equation, I can write 1 by f. So this is 1 by f1 plus 1 by f2. So this is f2. Okay. So this is the equivalent focal length if we combine two thin lenses. Okay. But this is valid for any, like it is valid for any number of lenses. So suppose you have connected, or you have combined 4 lenses having focal length f1, f2, f3, f4. Okay, so your equivalent focal length will be what? 1 by f equal to 1 by f1 plus 1 by f2 plus 1 by f3, 1 by f4. So if you suppose connected n lenses, so it will goes like 1 by f1 plus 1 by f2 plus 1 by f3 dot dot up to 1 by fn. N may be any number, n may be 6, n may be 7, n may be 10, or it may be more than 10. Okay, I hope it's clear how to find the equivalent focal length for the thin lenses in contact. So now I'll modify this equation. Now you see this is 1 by f. 1 by f is what? It is nothing but power of lens. So I can write, in place of 1 by f, I can write p. And in place of 1 by f1, right? In place of 1 by f, I can write p. So likewise 1 by f1, this is the power of lens for lens A. And for 1 by f2, I can write power of lens for this lens B. Okay, so this is how I can reduce this equation for the power of lens. And likewise, if you connect it, like if you combine 4 or 5 lenses, so it will goes like P equal to P1 plus P2 plus P3 plus P4, P5, like, and so on. Okay, it's clear. And if suppose one more, if you want to find the magnification of the lens, okay, magnification, you can write, it will goes like this: M, M1, M2. Say suppose if I take 3 lenses, so M1, M2, M3, right? If I take 4 lenses, this is M1, M2, M3, M4, like it is so on. Okay, so I'm writing for the general. Okay, I hope it's clear now. Okay, so this is counted as a important topic for the coming exam. Okay, so now we'll solve one numerical from the exercise. Okay, we'll solve one numerical from the exercise. Okay, dear students, you see in question number in your exercise 9.10 means question number 10. So here we have a question: what is the focal length of a convex lens? Right? What is the focal length of a convex lens of focal length 30 centimeter in contact with a concave lens of focal length 20 centimeter? Is the system is a converging or diverging lens? Okay. So what we have given, let's write what we have given first. Okay. So you have to write, so 9.10, so solution. So we have given, okay. So here we have combined convex with concave. So first they have given, say I will take the first focal length as a f1. So this is convex. So this is going to be plus. So plus 30 centimeter, and next is concave. So I'll take this f2. And since this is a concave lens, so its focal length is what? Minus. Okay. So we know how to find out now. We got the formula, right? So we'll apply the formula. We know that, okay. So 1 by f equal 1 by f1 plus 1 by f2. Okay, let's put the values. So this is 1 by 30 plus 1 by minus 20. Okay, so 1 by 30 plus minus what? It's become minus, so 1 by 20, right? So 1 by f. So what is the LCM? Let's find out the LCM. So this is 30 and 20. So I can divide by 10, right? So 3 and 2. Okay, so it's coming out how much? 60. So 60. So 2 minus, I can write 3. Okay, so from here I'll get minus 1 by 60 because minus 3 is the bigger number. So from here I need the value of f, so it will minus 60 centimeter. So this minus 60 centimeter will be the focal length of what? Equivalent lenses or combination of lenses. And the next part of the question they are asking, so if this, so they have combined this convex as well as what? Say concave, right? They have combined these two. Okay, so what the system is going to be? Is it converging or diverging? So you check this. If this is negative, the whole system will be what? Concave, right? And if this is positive, the whole system will be what? Convex. So here we got our answer in what? Negative, means the whole combination, the whole system will act as a concave lens. Okay, so this is a very important numerical. Okay, so so this is how we have finished this one, and now we will discuss some numericals. Okay, so now I'll discuss some numericals from the textbook. Okay, because last time, okay, so small numericals, okay, from the power of lens. Okay, so now it is page number 328, page number what? 328, and say example 9.8. okay, so I'll discuss question number 1. In question number 1 they have given if f equal to 0.5 meter for a glass lens, what is the power of lens? Okay, they have given us what? You have to write given. The power of lens is what? 0.5 centimeter. Power of lens, oh sorry, it's given in meter. Okay, so we have to find what? Power of lens. Okay, now it's very simple. Okay, so we know that P equal to 1 by f. Where is the power? This is power, so 0.5. So if I remove the decimal, this is 10 by 5. If I cancel out, this is 2 meter, or you can 2 meter inverse, or you can write diopter. So your answer will be what? For the focal length 0.5 meter, the power of lens is what? 2 diopter. Okay, you always make sure that you are going to write the unit. If you don't write the unit, okay, the half mark will be deducted from your answer. Okay. Okay, so dear students, we have been discussing that 9.8 numerical. So we have already done number 1, right? Now we'll try to solve number 2. Okay, number 2. Okay, because this is going to be very important for the coming session, means coming exam. So number 2. Okay, so let me remind you, because we have already discussed the lens maker's formula, right? Lens maker's formula, right? So lens maker formula, how to find? From the lens maker formula, we can find the refractive index, we can find the focal length, we can find the radius of curvature, right? Okay, so the formula, okay, let me recall the formula. This is 1 by f n 2 1, or you can directly write n1 also, minus 1 by r1 minus 1 by r2. This is the formula. This is called lens maker formula. And you have to remember one thing, okay, that focal length is in air medium. That focal length is in what? Air medium, because the whole apparatus or experiment has been done in the air medium. Okay, now come to the question 9.8, page number 328, and question number 2, Roman 2. Okay, the radii of curvature. The radii of curvature of the two faces of a double convex lens are 10 centimeter and 15 centimeter. Its focal length is 12 centimeter. What is the refractive index? Okay, so let's write what we have given. So in the question number 2, what you have given? Solution. So we have given radii of curvature, means we have given r1 as well as what? R2. So r1 is what? 10. R1 is what? 10. R1 is going to be plus, and R2 is what? Minus 15. Let me tell you why this is minus and why this is plus. Okay, now this is first lens, right? So if I measure its radius of curvature, it is on the positive side. So that's why R1 is positive. So another face is this one. So if its radius of curvature is on the negative side, that's why its radii or radius of curvature will be what? Minus. I hope it's clear now. And again we have given focal length. What is the focal length? That is f equal to plus, because you have to remember for the convex lenses focal length is always positive. Okay, so that's the data we have given, and what I have to calculate. So let's check what I have to calculate. What is the refractive index? In short, we have to find the value of n. Okay, let's use the formula. We know that 1 by f equal to n minus 1 by r1 minus 1 by r2. So 1 by f equal to, what is the value of f? What is the value of f? This is plus 12. So n minus 1. What is the value of r1? It is plus 10 centimeter. Minus, what is the value of r2? This is minus. So if I write here, this is minus 15, but minus minus, it will become plus. So I am directly writing plus. Don't get confused. Okay. So if we take the LCM and if we solve this equation, you please solve by using calculator, because now I have to save my time. Okay. So here n will be coming out as 1.5. This is the required refractive index of the given class. Okay. So now let's solve the question number 3. I mean the Roman 3. The same example 9.8. Okay. So now, so question number 3, 9.8. Okay, let's go through the question once. Okay. So a convex lens has 20 centimeter focal length in air. Okay, you have to focus on the question, because see, focal length in air is how much? It is 20 centimeter. Okay, they are saying convex, so I am taking this positive. Okay, next, what is the focal length in water? They are asking what is the focal length in water. Okay, what is the focal length in water? So they have given the refractive index of air, water. Refractive index of what? So I'll write in short, Ri means refractive index of, that is air and water, equal how much? This is 1.33. Okay. Next, refractive index. So refractive index of, next is what? Air glass. Air and glass equal to how much? 1.5. Okay. So now, first dear student, now you see, okay, so we have given two medium, one is air medium, another one is water medium. So first we'll write the lens maker's formula for air medium, and after that we'll write the lens maker formula for water medium. So let's first try to understand for the air medium. Okay. So now, so we have, or you can use, we know that we have 1 by f focal length in air. Now the lens, our lens is in what? In air medium. This is in what? Air medium. So when the lens is in air medium, means the ray of light is traveling, so ray of light is traveling from air to what? Glass. Air to what? Glass. Make sure, okay, the ray of light is traveling from what? Air to glass medium. So 1 by f air equal to n minus 1 by r1 minus 1 by r2. Okay, now, so what is the focal length in air medium? That is 1 by 20 equal. So n, now you check nicely, okay. So now ray of light is traveling from air to glass. So which one we have to consider? Air to glass. Okay, if you by mistake put this one, your whole answer will be wrong. Okay, so ray of light is traveling from air to what? Glass, because you have kept the convex lens in the air medium. So we'll write 1.5 minus 1 by r1, 1 by r2, because r1 and r2 the value is not given. Okay, now 1 by 20. Now 1.5 minus 1 is 0.5. Okay, this is 0.5. 1 by r1 minus 1 by r2. So if I transfer this 0.5 to the other side, so the equation will reduce to 1 by 20 multiplied by 0.5 equal 1 by r1 divided by 1 by r2. Say this is equation number 1. I'm just finding out the value of 1 by r1 minus 1 by r2, because I'm going to use this in the later part. Okay. So next, okay. So next is, we have placed, means we have immersed the whole convex lens under the water, okay, in water medium. Now our lens is in water medium. Okay, now you have to think that the ray of light is traveling from what? Water to glass medium. Okay, you have to mention this. This is traveling from what? Water to, this is lens is what? Made of glass. So glass medium. Okay, so now let's apply the lens maker formula for this. Okay, so I can write again you can write, we know that, or we have, say I am using the statement, we have 1 by f, but now the focal length is in water, means the lens is in water, so we will calculate the focal length in water. So equal to, now you have to remember, okay, you have to focus here. Now the ray of light is traveling from water to glass, so I can write refractive index of glass with respect to what? Water. So I will write refractive index, so n water divided by refractive index of what? Sorry, refractive index of glass with respect to what? Refractive index of water. Why? Because ray of light is traveling from water to glass. Okay, minus 1. So this is again 1 by R1 minus 1 by R2. 1 by R1 minus 1 by R2. Okay. Now, so what is the refractive index of glass? Refractive index of glass is what? This is 1.5. Refractive index of glass is what? 1.5. And what is the refractive index of water? That is 1.33 minus 1. So 1 by R1. Now, dear students, you see, if we see the equation number 1, we have the value of 1 by R1 minus 1 by R2, right? So what is the value of 1 by R1 and 1 by R2? This is 1 upon 20 multiplied by 0.5. Okay. So if you do the calculation with the help of calculator, your answer will be that is plus 78.2 centimeter. Okay, because shortage of time, dear students, so I can't do the calculation and all, so you please adjust with that. You try to calculate this, you just how to do it. So you just divide 1.5 divided by 1.3 and you just subtract minus 1 and then you do the calculation, you just multiply it. Okay, now you'll get some value here, but you have to make sure that this is the value for 1 by f. So you need the value for 1 by you need the value for f, so you invert the whole equation and you'll get this answer. Okay, okay, this is plus 78.2 centimeter. Okay, so this is about the numerical from what? Lens maker's formula. Okay, so next, so let me discuss one numerical from the exercise. Okay, this is question number 1. As we have already discussed mirror equation, right? I hope you remember the mirror equation, that is 1 by u plus 1 by v equal to what? 1 by f. This is mirror equation, and for the same we have find out the magnification, that is m equal to minus v by u, and this magnification can be defined as the ratio of size of the image, this is h dash, and size of the object h equal to minus v by u. So this is the formula we are going to use now for question number 9.1. okay, from the exercise. Okay, 9.1. so let's go through the question once. A small candle 2.5 centimeter in size, means small candle, this is object. So let's record the data. So it's given the size of the object, it is denoted by h, small h, so that is 1.5 centimeter, that is 1.5 centimeter is placed at 27 centimeter in front of the concave mirror. So this is going to be the object distance, so u, and you have to remember that object distance almost is always negative. Okay, so I'll write minus 27 centimeter. A concave mirror of radius of curvature 36 centimeter. So what is the radius of curvature of concave mirror? That is 36 centimeter. Okay, so that is radius of curvature is what? Denoted by r. So for the concave mirror, radius of curvature is negative. So this is 36 centimeter. Since in the formula we have f, right? We have focal length. So we can find out the focal length from the radius of curvature. So therefore, so we know the relation f is nothing but r by 2. So we can write minus 36 divided by 2 equal to minus 18 centimeter. I hope it's clear now. So this is the concave mirror. Okay, dear, so this is the concave mirror. This is curve inwards. This is what? Curve inwards. So here is the radius of curvature. This is negative side of the x, or where we always measure this against the direction of the incident ray. That's why this is negative, as well as we are placing the object in front of the reflecting surface of the mirror. So that's why object distance is also negative. Since the radius of curvature is negative, then focal length must be what? Negative. Okay. So that's the given data. So let's use the formula. So we can write. We know that 1 by u plus 1 by v equal to 1 by f. So we have to find out what? So at what distance, okay, you listen the question, at what distance from the mirror should a screen be placed in order to obtain a sharp image? Okay, they are asking at what distance we have to place the screen to get the image. It means that indirectly they are asking the image distance, means at what distance we have to put the screen. Since if we put the screen only, the image will form, right? It's indirectly what? This is nothing but the image distance. Okay, so we have to find the value of v. Okay, image distance. So now I'll reduce the equation. 1 by v equal to 1 by f minus 1 by u. Okay, now let's put the value of 1 by f, let's put the value of f and u. So what is the value of f? That is 1 by minus 18 minus, what is the value of u? That is minus 27. So minus 1 by 18 minus minus plus 1 by 27. So what is the LCM of 18 and 27? Let's find out the LCM. Okay, so 18 and 27. Okay, it is divisible by 9. Okay, I'm just dividing. Okay, because I'm saving my time. Okay, 2 and 3. Okay, so 9 multiplied by 2 multiplied by 3 is nothing but 54. So LCM for the whole expression is 54. So here I'll write 1 by v equal 54. Okay, now, so this is 18, so this is minus 3 plus 27. 27 is what? 2. So 1 by v equal to minus 1 by 54. But I need the value of what? Value of v. So I'll invert the whole equation. So v equal to minus 54 centimeter. Okay. So what is the image distance? So therefore you can write, we have to place the screen at a distance 54. At a distance 54 centimeter from the mirror. Okay. Now dear students, if v is negative means the image is forming again on this side, right, in front of the mirror again. It means that this is real image. This is what kind of image? This is real image, because it is forming in front of what? Mirror. So this is real image. Okay. So now we have to find, okay, next part of the question, we have to find the size of the image also. So let's find the size of the image. So again, okay, so we know that to find the size of the image, let's use this formula. Okay, h days divided by h equal to minus v by u. So now why I'm using this formula? Because we have given the size of the object. Okay, we have given the size of the object. So that is, so again we have h days divided by h equal minus v by u. So what I have to calculate? H days, right? So I'll do cross multiplication. H days equal to minus v by u multiplied by h. Okay. Now minus. So what is the value of v? Value of v is what? Minus 54. Minus 54. And what is the value of u? That is minus 27. Minus 27 multiplied by, what is the value of h? That is 2.5. Okay. So now I can write here minus minus plus, but here one that minus will remain here. So I am writing here in front of the whole expression or whole term. So now if I cancel out 54 by 27, how much I'll get? This is nothing but 2. Okay. So now 2 multiplied by 2.5. Okay. Now what is 2 multiplied by 2.5? That is 5, right? This is what? Minus 5 centimeter. Okay. What is the answer? That is minus 5 centimeter. Okay. So Now dear students, what is the significance of that minus? Okay, as I already told you in while we have been discussing the mirror equation, if this is minus means, now you see this is the principal axis, this is the principal axis, and here they are denoting the size of what? Size of the image. It means that this is below principal axis, and if this is above the principal axis, this is plus, and below principal axis this is minus. It means that our image is below the principal axis and its size is what? 5 centimeter. So image is what? Below principal axis, and that is minus 5 centimeter, means the magnitude is 5, and then this negative represents this is below. So since, as I already told you, V is negative, so image is what? Real. And again this is minus, so this is the object direction, object orientation. Now this is downside, upside down, so this is inverted. So the image will form at a distance 54 centimeter from the mirror, and the image form will be what kind of image? That is going to be real as well as inverted. On the next part of the question they are asking, okay, the next part of the question they are asking, if the candle is moved closer to the mirror, how would you like how the image is going to change? Okay, now this is a practical situation. If we move the object closer to the mirror, the image will move away from the mirror. This is the practical situation. You can type practically. Okay, okay. So this is about the solution of 9.1, and now you can try 9.2. Okay, you try to solve 9.2. Okay. So dear students, okay, so we have discussed lots of things today, like power of lenses, right? Power of lenses, combination. For the combination, we have discussed lots of important numericals, which has lot chances for coming year, means your final exam. Okay, so you please go through the questions and you try to solve the other similar numericals example as well as from the exercise. Okay, bye dear students.